Hey guys, Mr. Bowman here. Today's learning objective is in red and we are learning to use Pythagoras Theory to solve problems. So what makes this learning objective a little bit different is this idea of solving problems. And what we're doing is we're going to bring in real-world examples, real-world context for us to apply Pythagoras Theory as opposed to just being given a random triangle. And I've got the question here. We can kind of see up the top is meant to be a lighthouse, and this is meant to be a boat, and that's a cliff, and then I suppose the rest is the ocean. We're going to look at that context. But before we get into that, we just want to remind us, well, what are the steps of solving a Pythagoras Theory-related problem? Hopefully you recall that the first one is labeling your triangle. So labeling triangle. The second one after that was substitution. So that was a really, really important one. And then finally, after that, you were to solve. When we're trying to solve problems from a given context, there's a step that sits above labeling the triangle. And this time around, if you have a look at our question, there is no triangle. So what we need to do is when we're solving a problem, we need to show up, well, what exactly does our triangle look like? What measurements do we have? So we're looking to draw the triangle. Once we've drawn that, we can get into our three-step process about labeling the sides, substituting, and then go ahead and solve. So let's get into our question. Forgive the poorly drawn layout, but as I said, we've got the lighthouse, the boat, and the cliff. And we've got some information below. So we know that the lighthouse is 175 meters above sea level. So what that tells us is the top of the lighthouse all the way down to the beginning of the sea, that green part, that there is 175 meters. We also know that the boat is 337 meters away from the lighthouse. So this is telling us boat to lighthouse is 375 meters. So I'm actually going to draw a line connecting the boat and the lighthouse. So that there, 337 meters. And what that means here is we don't know how far the boat is away from the cliff. And that's what we're trying to find out here. So how far is the boat away from that cliff? So we've got our triangle, and you could probably assume the right angle would be at the base of the cliff and the ocean or the water. So we can get ahead and get into labeling our diagram. Start off with A and B. A and B, they always join to make that right angle. So let's say that's A and that's B, and opposite the right angle is always the C value. That'll be the 337. We're then going to write down our formula. So A squared plus B squared is equal to C squared. And from my equation, I know I don't know A. That's what we're trying to find out. I know B to be 175, and I know C to be equal to 337. So I'm going to substitute all of those in. So A is going to stay as A squared, because I don't know what that is. B is going to become 175 squared, and that's going to be equal to C, which is 337 squared. We're now just going to evaluate what these squareds are, and they're going to be big numbers this time around. 175 squared. So we've got A squared plus 30,625. That's going to be equal to 337 squared, which is 113,569. I'm then going to use my algebra. So I'm going to subtract that 30,000, get it on the other side. So that means A squared will be equal to, just using my calculator here, so that there is 82,944. I'm then going to get rid of my square. Opposite of a square is a square root. So I'm going to go A is going to be equal to the square root of 82944. And when I put that into my calculator, I'm getting 288 meters. So what that tells us is our boat over here is 288 meters away from that cliff. So guys, hopefully you can see the process that we need to follow when we're looking at Pythagoras' theories in context. Similar to the first three steps, label your triangle, substitute, solve, but we must come to grips and draw our triangle beforehand. So thank you so much for watching, guys. Now let's get into heaps and heaps of practice.